Hello and welcome. Hello and welcome to this episode of Streaming Frontiers, the only show in the internet about where no data streaming engineers has gone before. My name is Viktor Gamov, and I will be your captain as always in this fantastic live show. As everything happens on the show, everything is live. Everything is happening as you see it, meaning that if there would be some, the problems and something will not work. It also will be live. So for this, my dear people, if you're watching this live, I hope you're watching this. I'm just checking and see if anyone is actually watching this. Please write down in the comments where we're coming from. My name is Viktor Gamov. I am Principal Developer Advocate with Confluent here and coming to you live from not so sunny New Jersey today. There's just day before of national holiday of the Thanksgiving. I'm super excited. As you can see, I'm still wearing my the Halloween costume. So the Halloween spirit still runs very, very, very strong. So and today is going to be very exciting. Today is going to be a very exciting episode. Like for me, it would be definitely very exciting episode because this is something where we were able to like showcase this in person, how this was how it was done. And yes, today I'm talking about how we build this demo for current New Orleans. Let me switch my channel here. So before we start this, first of all, thanks everyone who joined us in New Orleans in person. It was very exciting event. It's the first time we're doing this in New Orleans. First time in New Orleans myself, and it didn't disappoint. It was great, great energy, and we're excited to do this next year as well. However, we're going to talk about New Orleans in a second. Just before that, I would like to talk about a few more things that's going to happen in 2026. So first of all, we updated, there's a new website for Bengaluru and London. And so you have dates for Bengaluru and London already. So if you are planning to attend one of those, please mark your calendars. And if you have data streaming story that you want to share, please do so, because we do have call for paper is open for both Bengaluru and London. So if you're in this one of those regions and want to speak and want to present your data streaming story, your AI story, the microservice integration, essentially everything that somehow would be something that the audience would be interested to learn. something with data, how your real-time data help power your AI pipelines and things like that. So I'm really, 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 really looking forward to see many of you there. The submit your abstract today. The call for papers will be open for another month, but don't wait until the end. Start thinking about your story, and as always, if you are need help to frame your story, to come up with the abstract, come up with something that will help you to kind of like a better express your story, don't hesitate to reach out. My team of developer advocates are here to help. If you need to help with the writing abstract, here to work on your outline. So please do. Bangalore and London are open now. Let's get back to New Orleans. Okay, I see at least LinkedIn stream works. Ivan, Alex, welcome to Streaming Frontiers. Thank you so much for supporting this. Ivan, Alex already been in multiple streams in the past. It's good to see you, friend. Now, since we do have a working relationship with LinkedIn, now check if someone is watching us on YouTube, please comment out something in YouTube if you see in hearing us. Now, let me remind you what happened in New Orleans.
Right now, I want you all to get your phone out of your pockets and scan this QR code.
You don't have to scan it right now, actually. It was a live event and it's a recording. But this is how we were encourage people to interact with us.
A mobile site. Keep the site handy. Don't close it. Keep it open. For the rest of the time, things are going to happen in this room. And your job is to capture them. Was that a cow? Okay.
Yeah,
well, capture it, friends. I trust you.
Fun episode of Cowbell.
Write it down. Explain what happens. Explain what you see. Explain what you hear. Behind the scenes, in our backend system, we have an AI pipeline that is going to capture all of your inputs, and it's going to show and summarize it right in the dashboard. So keep your eyes ready and be open. And listen, friends, I'm trusting you on this one. We need to know what is happening in the room as it happens.
So essentially, there was an idea that we can interact with the audience, and they would submit their requests. I unfortunately didn't have enough time. I was on stage, as you can see here, with the same costume, switching laptops because one laptop didn't work, and we worked with the different laptop. There was a lot of fun. And today I have a little bit more time. I have a little bit more time to talk about this. As you can see here, I didn't have much of the facial hair on the stage of current, but now it's November, so I am still wearing my November attire. So if you want to go watch how I was talking about this during the keynote, actually, but let's try to see how everything works under the hood. So first of all, a friend of mine and colleague Robin wrote a blog post about some of the internals already. We're gonna cover some of those, but I want you kind of like a follow whole thinking process as well, and I will explain how everything works. So as you heard, Adi, we were inviting audience to submit a request, meaning that if you will be sitting in a room and you might hear or see or notice something that is happening maybe on the screen or on the stage or in the room, and you just need to go and submit this into the front end application that will be taking your considerations into account. And yeah, I mean, like I think that was kind of interesting idea to do interact with the audience. So let's start with this. Let's start with the very beginning, how this would work. So the architecture of this demo, I think I might have even um, where's my project description? Blah blah blah. Yep, I do have some diagrams of this application. Initial idea is, oh, I'm not showing this. I'm sorry. Okay. So the initial idea of this application is that we will get the mobile front end. Users will be submitting some messages. We're gonna send this into my web application that will include Kafka producer, and those messages will be stored inside my Kafka cloud, my Kafka cluster that runs in Confluent Cloud, and we're going to talk about this part in a second, but idea is that this part, this kind of like agentic system that will do something, in this particular case it will run the summary, and after that we publish this the summaries back to Kafka topic that would be used by front end application that will be display this um, in this on the stage. Now, so as you can see here, there's two microservices. One microservice will be producer, super simple. There's nothing really exciting except the part that it works, connects successfully to Confluent Cloud, and just works just great. So let's start with this. Let's start with producer, and after that we'll see how this will work. Now, for deployment, I use this platform that's called Coep. I used Coep for a while in the past when I was at Kong. They were cool, and they have some cool capabilities. One of the capabilities that we explore is kind of like if no one used this application, it will actually go down and will wait in when the first request will come in. It's kind of like a serverless approach. I'm not gonna run this not gonna run this right now in the cloud. I'll just run everything locally in my development environment. So two applications. So I call this whole thing, I call this as a chorus because it's the collection of voices from the audience. I think it kind of makes sense. I think it's kind of cool. When the people will describing everything what happens in the room, it would sound like a chorus. Now, the application that will collect all this data, my producer, it's called Ensemble. I mean, Ensemble, right? So data would be produced to the music would be created by Ensemble. And this Ensemble, it is a Spring Boot application. So many of you know that I'm a huge fan of Spring Boot, and all things Spring. They have an incredible integration with Kafka. It's called Spring Kafka. The way how it works. The question to the audience, like question to Ivan, Alex, and a few other people who are watching this right now. Are we good with the white the themes? Never tried like a dark themes for this particular stream. I don't know if this work a little bit better than white theme. Write down in the comments. I'll stick for now with dark theme. I don't know. It very aligns very well with the space theme. White is good. Okay, Tony's back. White is good. Okay, let's go back with the white theme. Yeah. Now, in the Spring Boot, there's a concept of Spring template. This is something that would be wrapper around my Kafka producer. Essentially, Spring template. This is something that we will be will be using in the application. So essentially, one of the things that what the Kafka template will do is just send, get the user messages, get device ID, get message. Now, what is submission message? So we are wanted to collect some of the interesting information about the users, but not necessarily we want to connect any like user identifiable information. So we're not in the business of collecting this type of data, and we don't want to share this information. So it's kind of like we'll collect some information that allows us to get the idea what the people are sending. So in this particular case, device ID, it is hash that will be generated on the front end that allows us to distinct some of the requests, because we're also running a kind of like a leaderboard that allows us to get some people. Some people get super excited about leaderboards. We'll talk about this in a second. Now, device type, user agent, browser type, text, and the timestamp. We're going to be using this in order to do the windowing, some of the jazz. And we get this from the front end submission message, and we send this into the Kafka topic. So let me show you how this would look like in. Just want to make sure that my connection to my Kafka cluster should work. And this application would run as a Spring Boot web application. Looks like successfully connected to Kafka, and this application would use port to connect. So let's take a look. What does it do? Oh. Looks like there might be some cached information. Yep. So there was some cached information, and I always like to open the developer tool so I can always disable cache. So there would be no issues. Now, works great with the light and dark theme. So if you prefer to switching back and forth, some of the interesting things that you might also see here, you don't see it here right now, but let's see if we are getting anything. So first of all, when this application starts, it also produces, before you even start sending anything, it produces a heartbeat message. So heartbeat message would allows us to advance some of the watermarks on the Flink site. We're going to talk about this in a second. But essentially, there would be some, this application as a separate process. There's it's going to be publisher, but we're looking for service. So there's a heartbeat scheduler that will be running every 30 seconds. We'll be submitting a heartbeat message. As you can see here, we're still using this submit message, device ID, heartbeat, system, and device type heartbeat. So this thing will be filtered out when we need to do actual processing. So as you can see that those messages are coming in a big chunk. If I say, hey, from streaming frontiers, and I'll click submit, it's sent. So now I'm getting these messages. Bouncy Buffalo, that's my name. This is something that I will be identified as. Device ID, that's some of the cache, the UID that would be stored. Device type Android. Why is that? So I'm using this the browser tools. Let me switch to more appropriate things. Say iPad Pro. Hello from streaming frontiers. and iPad. And this message now should include, I see it still remembers me as a bouncing, it still remembers me as a bouncing buffalo, but still thinks that it's Android because it runs inside a Google Chrome simulator. So that's why I think. Another thing is that I do have some secret debug menu that allows me to see what is going on here. So in this particular case, even though it identifies as a mobile Safari, it still feels like it is Android. So go figure. I'm not a front-end developer, but hey, that works. So this information captured and sent to Kafka topic. Pretty neat. There's nothing really. There's nothing exciting to call home about this part, except this also exposes a REST endpoint, and this REST endpoint can be invoked programmatically. So I use the programmatic approach to generate some of the load, so our application can work with something. But I really like how some of them, the people who were watching this live, or it was online, or in New Orleans room, they decide, okay, so what about I'll go and hack this API. There you would notice that some of the person would try to win the live board, so there was no malicious intent. But the people were trying to win this game, even though there was no winning or losing. So I do have a test submit script that is essentially generates a bunch of sentences that will be describing this event that happened on the stage. Once again, we wanted people to be engaging in this presentation, so we were orchestrated some of the events that happened in the room. So let me see if I go say test. It's going to be something like scripts test submit. Okay, so probably incorrect test. Yeah, so that would be correct. So if I would use my localhost URL, so in this case, it will hit correct endpoint. Now, I start submitting. It says Rapid Buffalo. If I go to my Confluent Cloud, I start seeing this key. It was test robot. So that's my testing application identifies itself as a test robot. I think I also do, and this the system heartbeat test robot. Where's the test robot? The venue is raining confetti from above. That might be potentially confetti happens over there. So no problems. And if I'll just do, there was also say like a data monster stuff. Data monster file is not found. Okay, so maybe I should need to go inside the script directory. And let's do this one. So some data load, data monster test. People commencing throwing small data monster pets at the audience. So data monster is the new exciting, the mascot is called Batchy because, Batch is bad. So that's why data monster is horrible. And the Batchy would appear on the stage or people start throwing things. So we also wanted to try this out. Again, there's nothing really fancy about this except it is pretty neatly organized script that says like how many requests per second was sent, total submissions, blah blah blah. So this is how it's implemented. Now, I would write this stuff myself, and I'm totally cool with this. So that if I would sit down and write this code, but I was also curious to explore what the kids called vibe coding, but what I called AI assisted engineering. So for this, I would use this neat tool called the Kiro, which is Amazon new kind of like AI coding system. And what it does is it allows me to implement what is called spec-driven development. So I would write a requirement for my application. So in this particular case, say we're going to talk about, let's talk about Kafka Heartbeat. So how I implement this feature. So I would go in the chat and start talking to Kiro. Specifically here, there is a vibe or spec. Vibe doing the kids these days, I'm serious software engineer, so I'm doing spec-driven development. So first thing is that I would come up with the requirement. Like, okay, so I want this system to implement a periodic heartbeat mechanism to ensemble application. That's my producer application, as you remember. That will send empty marker message to Kafka topic. This enables Flink consumers to advance watermark during period of low or no user activity. Ensuring timely processing on windowed operation, preventing watermarks to stall. Now, so this is the requirements, and all these requirements will be arranged in user stories. One requirement, Flink stream processor, I want to receive periodical heartbeats, user message, and there would be some acceptance criteria. Based on this specification, based on these requirements, there will be designed that would be using actual API. So in this particular case, we're gonna go into requirement 1. That would be covered by, and look at this. It also has very nice ASCII art that would say that it will run the scheduler, execute the heartbeats, submit message, and delegates to the publisher. So we're going to be using same publisher, same Kafka template, and we will produce user messages into and this design includes like what the messages will be used, data model. And this also something that I'm not writing. This is the I'm communicating to IDE, and IDE will provide this design. If I'm cool with this implementation, I know that some of the test cases needs to be implemented. So I'm also saying that that's totally cool. Let's go with actual implementation. So the actual implementation will be driven by set of tasks. So every design decision, and that will be supported by requirements. So in this particular case, task 1, create heartbeat properties configuration class. That will include heartbeat intervals, specifically, where's my config, heartbeat properties. That will include enabled intervals. So I want to be able to disable those. So there's 2 things, like application heartbeat. Also application.properties, and that's my heartbeat that would be injected into this configuration file. And the way how I force Kiro to know which APIs to use and what kind of libraries to implement this, Kiro has the very interesting thing called steering documents. One of the things that it has, the product that explains essentially what kind of, where's the tag? There's a tag that explains what kind of technologies needs to be used, what kind of version of the libraries, and all this kind of stuff. So this is the steering documents that will be like used all the time when this Kiro thing will be communicating to LLM. And another thing is that there is a very critical rule, inclusion always. It says must consult first of context 7 MCP. So documentation and up-to-date information is super important. LLM needs to know where to get the data from the recent, latest and greatest version of applications. And thankfully, with the help of community and the help for the people who run this context 7 MCP, now we have access to latest and greatest versions of Spring AI, Spring Boot, and all these versions. So every time when this system, this Kiro ID needs to get up-to-date information, it will go to Context 7, search for the library, get the snippets of the library what needs to be used, and will implement this in my feature. So this is how this will appear. This like the totally legitimate and fresh and up-to-date APIs will appear in my design, and after that, eventually, they will appear in my producer application that I will be implementing. So once again, we start with requirements. We're going into design phase, and we everything is under control. Like this is the stuff that stores in your file system. You will be able to go and modify this afterwards. It is also going to be some sort of like a memory of your application if you decide to switch with a different agentic coding tool, or you just want to pass it to real developers who will make this thing better. This this vibe coding thing would be implemented by real developers. Now, if you haven't tried it, just try it. It's super exciting. Now this application still runs. Now let's get back to the structure. We're gonna back into project description, markdown that everything started from. Next thing is that we need to have a front end that will be listening this LLM summaries topic. So let's take a look. So what we have in LLM summaries. There's nothing here. It's actually would be here. So I will show you what it would look like, how the summary would look like. And stage, dive, electric route, iceberg, data lakes dominate. So let's see if it gives me any fresh messages, not from the beginning. Because let me see if we have this. I think that there's some old messages from the past. I'm not sure if my AI pipeline works, but I do have idea how I can demonstrate this if the AI pipeline not gonna work. So message from Tony. Totally missed the beginning. Glad this magical appeared after frontier moment. Okay, Tony, you scare me and you sound like LLM. Are you a real person? Yes, they have some. Thank you for this applause, I guess. Thank you. All right. Now, second part is the dashboard. Let's see if I can run the dashboard. In our window, let's make it bigger. So I'll just do. I need to make sure that I'm running on the right port, so it will not have any port conflicts. Now, second application that will display all this information, I call it resonance. Kind of like, in order to something happened, there should some of the messages or some of the things that our ensemble produce, those wave needs to kind of like correlate and somehow get very close. So because it's going to be summary, so we need to extract some of the things that people see, and those things are common. So that's why I call it resonance. Resonance dashboard. That's the application that will be doing this. Again, we'll be using Kafka. Summary consumer that will be reading data from so summary consumer will be listening messages from the summaries Flink topic, and those messages will land in Avro format. We're going to talk about this also in a second. And after that, the message will be passed to this broadcast service. So the broadcast service, it's the broadcast service. I want to go to yes, WebSocket broadcast service. So this WebSocket broadcast service will get the message and send this into WebSocket client and read this on the front end. So let's try to run this application YAML. Let's see if I do have a server port specified somehow. No, I don't think so. I don't think so, but it should be something that's not difficult to do. Server port. Where is it? Server. Can I do this? What was the name? I'm sorry. My bad. What was the name of the server port? Okay, we're gonna go in. It's on top of Spring, so it's go something like server. Come on. Server Jetty 90. Can I do port? I don't understand. Why server? Well, because it's already covered here. Okay, perfect. We're gonna go with server ports in 1991. So we're gonna do resonance. And resonance dashboard boot run. So in this case, we're going to okay. We're gonna go Gradle. It's ensemble. We're gonna go with resonance dashboard boot run. Let me see. Where's it? Resonance. Yep, this is what I was looking for. And we do have environment variable, so should be fine. Now, this is going to be my... Okay, so dashboard will be a list. Okay. All right, so it's connected. And my localhost 81. Connecting to event streams, so it sees favicon, so receive the messaging, this is lightboard. So let's see if I will be able to, first of all, generate something. So in this particular case, remember my script was a test. Test submit. Okay, because the different port. Okay, ensemble port. Let's see. It will submit some messages about this. So leaderboard now updated with the 400 submission. So so this is the, let me close this. Let me disable this. Yeah, so it's going to be normal. It's going to be normal information. So this is how the people would try to achieve, because this is like a simple, we receive the messages and run the running aggregates. Maybe next time I should run this as a Kafka Streams application. That's the good idea. So if I would say ensemble and just do test. Test submit. Now Rapid Buffalo will appear here. So you hopefully you get the gist how it works and how this will work. Now, I think right now is missing is that how this stream connection works. So let's talk about this. So two things before we're going into this, route. The first thing how I approach this, I say that okay, so what if I would just like use something like agentic frameworks like Spring AI and implement this summary. So what I end up doing, I implemented this very simple application. So Spring AI is a great framework for if you're building some agentic applications, you're building some chatbots. Anytime we need to integrate with some external like LLM style things. And one of the things that Spring Boot has is integration and working with MCP server. So the way how it would work, we're submitting this query, and we also ship this set of how it's called, a set of tools that LLM might potentially use in order to get some external information. So the LLM by itself doesn't know anything about Kafka, isn't thinking about the external world, but we can provide some tools that LLM can express intent to invoke. So it will take a call to this MCP server, which our application will call, collect the required information, send back to LLM. LLM will do something with this. And also, if they want to invoke this tool, it will send the request back. So in this particular case, I will be using this MCP Confluent server. So what it does, let me show you. MCP Confluent. It is a MCP server that is publicly available. It's open source, but you can connect this to your Confluent cluster, Confluent Cloud cluster, and expose information inside the Confluent cluster in this for the LLM. If you don't know what I'm talking about, there's a few resources that you can go and learn from. So one of the resources is called Confluent Developer, and you can find this live recordings of the MCP expedition. This is where I will start exploring this. I hope you will enjoy and watch those. Also, there is a YouTube channel of yours truly, kind of like a personal channel. So it's going to be Viktor and Gamov. I recently recorded a video that will have full explanation of this MCP stuff. So recorded at the AI by the Bay, great conference. So if you want to watch this, you can go and see there would be much more details about MCP. I'm gonna talk about this right now. But imagine this, it's something that LLM would use in order to get external data. So first of all, we're going to start with system prompt. Your writer generating concise summaries for live events on live CD, the lead LED display. Consumer messages. Now, consume messages from the 5 minute from Confluent Kafka topic. Use consume MCP tool with provided connection details. Return JSON. And after that, those messages will be consumed from the Kafka topic. Generate the concise 10-word summary and push it back to LLM summaries topic using MCP server. Now, so let me run this as yes, our key is here, so I'll just do boot run. So what it will do, it get all these messages, will go to LLM summaries topic. Right now we don't have anything. And we should see something in very few seconds. Okay, so we submitting. That's the message that we sent to LM. I'm using Claude. User messages topic will be consumed by my application through MCP server. Send this information back to LLM. LLM will do the summary, and after that, ask us to produce data back to LM summary. So here we go. Do we have summary? No audience observation detected in this time frame. So looks like it was not able to read from my topic or whatnot. So for the last 5 minutes, let me do it one more time, because maybe script was not maybe script was using different username. Let's see if we can freshen up and run this one more time. Let's run this one more time and see if we can get some user observations. Again, last 5 minutes from Confluent Kafka topic, those messages from audience observations that just happened. Avoid processing root humor, bad words, assume people are PG audience, publish summary. Here we go. It's only consumed for some reasons only heartbeat messages for last 5 minutes. But at least it gets something, right? So at least it's a system monitoring activities, no audience messages detected. Here's a couple problems with this approach, as you can see already. So first of all, you need to kind of like run this manually. There would be the moments where I missed this time frame where these messages will be available. So we need to do better something with this. So Spring AI is great. I still, but it still feels like a batchy, right? Batchy. No pun intended. Now the batchy. So this is where was this my friend with his like Jedi skills of where is it? Where's my another window? With my Jedi skills of SQL comes into play. Now, during day one keynote, we announced that we're extending some of the capabilities in our Flink AI offering inside the Confluent Cloud. So we decided, okay, so what if that's kind of like it makes sense, right? So use the Flink AI and in Confluent Cloud to do this. So one of the things that we did, and let me go into the code. Now we can get access to same like Anthropic models. We use Amazon Bedrock as our kind of like a proxy and our hosting solution to interact with these models and help us to kind of like a slice and dice where and what teams are using this based on the API key, and also helps with the billing. So it's still Anthropic models, but provided by Amazon Bedrock. Now, we need to create a connection, and the way how this would look on Confluent Cloud. Sorry, I lost my connection to Confluent Cloud. I'm gonna go and enter my super secret passwords and stuff like that. Open the password app, and do I have it? No, I don't. Where's my passwords? Yep, my password. Once again, logging in here. So we're creating external connection to this Amazon Bedrock. So how this would look like. There's a current demo, integrations, connections. And this we connect to date modified today because I need to update some of the connection details. So that's the connection. Next thing is that whenever we need to change this, we're gonna do this through the script. We use some tooling here. Now for user messages, we need to add watermarks. If you want to learn about why watermarks are important, fantastic website. Robin was one of the producers of this website. If you want to learn about watermarks, interactive demo, it's fantastic. Just go there and learn how to play around and learn about watermarks. Going closer to the end. Now, we need to have a watermarks that would be issued every 5 seconds, so we can have some sort of like a ways how we can identify messages that were submitted across these intervals. So next thing is that we're creating a model that will be using our connection to Bedrock, and this model will allows us to provide some system prompt that we're going to be calling. So in this case, create the model. Where's the Flink? We're gonna do this models, and my model is summarize audience messages. That's gonna be the model that we're getting input. So in this particular case, the messages MSG will be our input. Or output JSON. And this model will generate us a summarized message. So first model will be just just summarizing, and another one we also want to have some sort of filtering. Remember in the project description, I really want this agent to perform filtering, so we can remove some of the root words and all this kind of stuff. And after that, the run summarization. So we run this in 2 phases. First one is the prepare, so we filter words and ship it next. So the next one, we're going to be using the 90 seconds hoping window, and this window will be advanced every 5 seconds. So it will exclude all empty and heartbeat messages, but only messages from the users. And after that, so we're gonna get the summaries. Where is it? Select from window messages, and we will send this into summarized audience model that we will run for this hoping window. And after that, the LM summary part 2. Let's see if it's let's see if this stuff is still running. Should be fine. Select start. So let's see if it has anything in the LM summary right now, which is essentially LM's up. Sorry, it's a wrong, not LM summaries. We are interested in LM summaries Flink. This is what our Flink stuff will do. Will do the result. So get the result from this LM summary PT2. That will include some information about window, summary, raw messages, and message count. Let's try to run. I believe there might be some. Let's see if we get any messages here. So let me try to once again run some load. Where is it? That's here. Test submit. This speaker sucks. As you can see here, there's some of the messages that we really don't want to display because they were like raw and not very kind of like not very pleasant. So we were also wanted to filter those out. So those will not be finally displayed on the on this application. So let's see, where's the dashboard? Still no connecting stream, so there's no Flink, there's no fresh data for some reasons, and I'm really surprised this. Let's see if it's the, so this topic, PT, waiting, new messages, no? Maybe my, I'm curious if I need to do anything else after I refreshed my tokens. But the idea, again, idea would be this data from Kafka topic will be performed, collected by Flink statement. This statement will ship it to LLM, and LLM will provide us a summary. So I need to check, maybe there's a connection, something, because I'm using some like a corporate access to this. Maybe those are not particularly working. There's some messages. Let's see where's the last message came in. Yeah, it's from the long time ago. This is kind of like long time ago. Let's see if this from, there was a summary PT2. Why it's not showing us whatever I need it to show. Maybe again my connection to external model is not working correctly. So running statement, start time, it's right now. When, yeah, looks like it's not updating. So let's see what is happening with this PT2 statement. Do I need to PT1? It's here, so it should work. But what is happening before? So create a table PT1. Let's see if we have any new messages in PT1. So we do, like I said, it's going to be our yeah. So let's see if it's if there's some messages coming in. No, looks like some connection to model is broken. I think I did altered connection, and I don't see. Let's see, models, external tables. No external tables. Prepare summary for display summary. So summary audience messages. That's model. Summary audience messages. It works, and it should work. So the model is working now. Something is not right here with the connection, but I'm not gonna waste this time to debugging this, even though there might be if I have a few minutes to debug. Let's see if we can see this. We're gonna go with the compute pool. We're gonna go with GCP. And let's see if there is some connection. Filter. No, there's no filters. Okay, so let's go with the link statements. Alter connection. Let's see if it's successfully executed. So yes, it looks like there's no issues. It should work. But anyhow, so I need to explore this, and as always, this exploration of finding the working solution is always happened after I'm done with the show. So I'm not gonna spend some time on this now. So what you now know how we build this? It is Spring Boot for Kafka producer and consumer. For building front end, I 100% vibe code this. The front end, the things that you see here, it is just like beautiful magic of vibe coding, spec driven development. Let's stay professional. So spec driven development with covers this WebSocket connection. Let's see if we still have it. Yeah, WebSocket connection works, and we're getting the information about the topics. And obviously, Confluent Cloud in between. It's data driven based on the data that will arrive. We will be able to always the security and the API tokens always coming into. Let's see, maybe Robin has a secret of this, how we can. Yeah, so read the blog. In the blog is pretty cool. It has like all things that is required to build this type of application inside the SQL. You know, sometimes you feel like maybe SQL is not right language for this, but hey, it's pretty cool. It's already someone will be running this for you, so you don't need to deploy this application, and it will work close to your data. You don't have to have like intermediate some sort of the intermediate system like MCP that will be consuming data for you and submitting data for you. So everything is built in. It is actually pretty cool, and I'm personally looking forward to explore more on Flink AI and Confluent Intelligence. Like one of the things that is coming next year, I will definitely spend some time to show it. Is what's we called the context engine that would be essentially MCP server that would be available out of the box. So with this, as always, my name is Viktor Gamov. Please, if you like this, go thumbs up in YouTube, write a comment under this video. We also publishing very cool Confluent Developer podcast. Just go there, find the episode that you like. We are inviting very interesting guests, so stay tuned for very interesting conversations. And with this, for those of the watching me in the US, and I want to say thank you in this Thanksgiving week. Thank you for being part of Streaming Frontiers. I'm extremely excited to do this show. I wish there would be a little bit more interaction, but I'm getting a lot of kind of like feedback based on like afterwards when the people watch this in their setting. Maybe after work, maybe it's not a very good time for to be during the day. But hey, it is what it is. Now, my name is Viktor Gamov. If you want, where is it? Where is it? I do have this. Yeah. If you want to try Confluent Cloud, there's the QR code that you want to try it out. Confluent Cloud, where all these like magical things can happen with your data. My name is Viktor Gamov, and as always, have a nice day.